Now we'll discuss about nature and causes of faults. So here, due to weather conditions, equipment failures, human errors, smoke or fires, the faults may occur. So weather conditions means lightning strikes, heavy rain, heavy winds. So the environmental conditions interrupt the power supply and also damage electrical installations. Equipment failures means the electrical equipments like generators, motors, reactors, so cause a short circuit faults. So due to that, high current to flow through the devices and damages. Human errors means selecting improper rating of equipment, that is electrical conducting parts. So due to that, problems may arise. Smoke of fires means ignition of air due to smoke particles, and this flashover causes insulators to lose their insulating capacity due to high voltages. And fault statistics state that types of fault: three-phase fault is occurrence is 5%, and line-to-line ground faults occurs 10%, line-to-line faults is 15%, and line-to-ground faults is about 70%. Consequences of faults: so damage to the equipment due to abnormally large and unbalanced currents and low voltages produced by short circuits. Explosions may occur in the equipments which have insulating oil, and this may result in fire and hazardous conditions to personnel and equipments. And at the risk of synchronous motors in large industrial premises falling out of step and tripping out. So these are the fault conditions: a three-phase fault, line-to-line fault, line-to-ground fault, two-line-to-ground faults, short circuit calculation. The fault type is a single phase to ground fault, and next is the short circuit calculation. Fault type is line-to-line fault. In the diagram you can see how the line-to-line fault has occurred, and three-phase fault, how the three-phase fault has occurred. Short circuit calculations. Next is the types of faults. So under normal conditions, power system operates under balanced condition. So this condition is disrupted due to faults in the system. That is, short circuit fault occurs when insulation of the system fails, resulting in low impedance path either between phases and ground. So this causes extensive high currents to flow in the circuit. So the short circuit faults classified as symmetrical and unsymmetrical faults. Symmetrical faults is all three phases are shorter to each other and the ground also. This may occurrence is rare. Severest of all types of faults. Fault current is maximum. In unsymmetrical faults, only one phase or two phases involved. That is line to ground fault, line to line fault, line to ground fault. So here we'll discuss about line to ground fault. That is, general case single line to ground fault has occurred. Assume that ground fault takes place in A phase. The diagram. So in many industries, normally phases are said to be A, B, C instead of R, Y, B, though they represent in same thing. So EA, EB, EC are the generated terminal voltage per phase. So the sequence current is given by three equations. Next is the line-to-line fault. So line-to-line fault is when two conductors are short-circuited. That is the line-to-line fault. The fault impedance is assumed to be ZF, and the lines between B and C, so that the fault can be symmetrically with respect to the reference phase. So the zero sequence component of current at phase A is given by the equation 1, and the component of phase A is expressed by positive sequence component by equation 2. So with the equations we have formed a sequence current by matrix method. Thank you.